In this problem, we're going to, again, calculate the medical dosage based upon the patient's body surface area. But this time, we want to calculate the body surface area using our nomogram, our chart. And you have examples of those charts in those pages that you downloaded and printed from the website. Problem 3, the order reads, I feel good, ooh, that's one of our favorite drugs, 50 milligrams per square meter. So the administration of the drug is 50 milligrams for every square meter. And again, when you see that square meter, when you see the M with the exponent of 2, that means body surface area is involved in calculating the amount of drug this patient should receive. The order reads, I feel good, 50 milligrams per square meter. If each tablet contains 25 milligrams, all right, so one tablet contains 25 milligrams. How many tablets would you administer? All right, that's what I want to know. How many tablets would you administer to a patient who is 183 centimeters tall? That's metric system then, isn't it? 183 centimeters tall and weighs 92 kilograms. Use the nomogram to approximate the body surface area. Well, let's take a look at what a nomogram looks like. Here's an example of a nomogram. And you can, again, look at the ones that you've printed out. And if you haven't, you may want to pause the video and go print those out so that you have them to look at. The nomogram consists of 3 scales. The center scale is where we read the body surface area. The left-hand scale is where we read the height of the patient, and notice it has 2 parts, one part in centimeters and one part in inches. And the right-hand scale is where we read the patient's weight. The left-hand part of that scale is their weight in kilograms. The right-hand part is their weight in pounds. So if we were going to use a nomogram, to estimate the body surface area for this patient. Since we have the information in metric systems, in the metric system, we will use the left-hand scale of the weight and height scales. So the easiest way to do that is to take a straight edge, or even just the edge of a piece of paper will work. And you lay it across so that you are hitting the height in the left-hand scale, which in this case would be 183 centimeters. You're hitting the weight in the right-hand scale, which in this case is 92 kilograms. So you take your straight edge and you lay it across there so that those 2 figures are being intersected. And then you can read with your center scale the body surface area estimate, which in this case comes out to about 2.20. When we use 183 centimeters for the height and we use 92 kilograms for the weight, the body surface area is approximately 2.20 square meters. So this patient would have a body surface area of 2.20 square meters, approximating it with the nomogram. Now, there will be a little difference if you use the formula like we did in the previous problem. The figures are not going to be identical. There's a little difference between using the chart and using the formula. But it must not be significant enough, or the folks in the medical profession would have said, this is the way you always do it. So there's our body surface area. That's where we start. And then we bring in the rate of administration of the drug. The patient should get 50 milligrams for every 1 square meter. So those square meters cancel, and if we simply did this arithmetic, we would know how many milligrams of the pure drug the patient should receive. And now there are 25 milligrams in every tablet. So we can bring that in for a conversion. 1 tablet contains 25 milligrams of the drug. Milligrams of the drug cancels, and I have left my unit of measure I want, tablets. So now I can do my arithmetic. 2.20 times 50. That gives me 110. Divide that by 25. Gives me 4.4. 4.4. But again, we don't want to over-medicate. and we probably can't administer 4/10 of a tablet. So we would administer to this patient 4 tablets. So you can see sometimes when you're calculating the dosage for a patient based upon the body surface area, you're probably going to be giving the patient a little bit less than what truly is indicated. But we never want to over-medicate, so we always go down to the next unit when it comes to calculating the number of tablets or capsules that we might administer to a patient. So in this problem, we had to first of all use our chart, our nomogram, to find the body surface area of our patient. Then we could multiply that by the rate of administration, by our conversion fraction that got us from milligrams to tablets, to determine the proper dosage for this patient.